Hi, we are from group 214, team number 4, made up of me, Elizabeth, Data, and Miguel. We'll be talking about the carbon family. It's also known as the group 14 or the carbonoids. This family is located in the group 14 and includes 3 metals, 2 metallics, and 1 non-metal, for a total of 6 elements. We are going to focus on the germanium, that is the number 32 on the periodic table. It is represented by a Bohr model, and well, its atomic number, we can see that it is 32, so we have 32 electrons and 32 protons. The electrons are the blue balls that are in the orbit, and the protons are the green balls that are in the nucleus. Then, because of its atomic mass is approximately 72.634, we can see the red balls that are about 40 and represent the neutrons of this metalloid. Just to explain a little bit about the electron configuration of this family, elements in the carbonoids family have an electron configuration ending in ns2 or np2, meaning they have 2 electrons in the outermost p orbital. As you go down the group, the principal quantum number obviously increases, indicating that the outer electrons are in higher energy levels. This configuration favors for the formation of covalent bonds, although in heavier elements like tin and lead, more metallic behavior is observed. These 2 metals also usually have an electron configuration of 2 rather than 4. You see, due to their configuration, carbonoids tend to have 4 oxidation states due to their 4 valence electrons, but in heavier elements. 2 is more common because they have more difficulty moving as their outer electrons. That will be everything that I'll be explaining, and the next topics are going to be explained by my partner. Thank you.
Place in the table. This family can be found in vertical column number 14 of Mendeleev's periodic table. It is in the p block, and as we mentioned before, its 4 valence electrons make it prone to form covalent bonds and, in some cases, ionic bonds. In addition to this, a transition from non-metallic to metallic elements can be observed, which influences their chemical and physical properties. But we will see this later. Before that, let's explore their characteristics. There are some rules that are repeated throughout the periodic table, known as chemical trends. Some of the most important ones are the atomic radius, the distance between the nucleus and the last energy level, which increases as we move down the family because they have more and more electrons. The ionization and electronegativity, which have to do with losing or gaining electrons, decrease, making it more difficult to lower elements to attract or lose these particles. And likewise, electron affinity also decreases as we move down the family. As a conclusion, we can say that the carbonoid family stands out not only for its diverse properties and chemical behavior, but also for its enormous relevance in daily life and modern technology. From carbon, fundamental to life, to silicon, key to the development of electronic devices, its applications span essential fields. Although some of its elements, such as lead, have been discontinued due to their risks, others continue to open up new possibilities for scientific and technological development.
Moving on, we have their physical and their chemical properties. Their boiling and melting points decrease as we descend the group due to the weakening of bonding forces. Silicon and germanium are notable examples of the family that behave as semiconductors, acting as intermediaries between conductors and insulators, as is often the case with metalloids. With these characteristics in mind, we can note the diversity of behavior observable in group 14, which act as metals, non-metals, or metalloids depending on the position. Some important facts is that all of its elements react with hydrogen, oxygen, and elements of group 17, which are the halogens. Carbon, the first element of this family, is so important that an entire branch of chemistry is dedicated to its study, organic chemistry. It is one of the primary elements for life, and it is also widely present in the environment, appearing as graphite or diamond, and as nanotubes or graphene, with applications in nanotechnology. Its metalloids, silicon and germanium, are used as semiconductors. In the case of silicon, it is also the second most abundant element in Earth's crust, surpassed only by oxygen. Tin is used in alloys, and lead has been largely eliminated from our lives after we discovered it is highly poisonous and a health risk, as we mentioned before. But one of its most iconic uses was in the pipes of ancient Rome, hence the word plumbing.
Thanks for watching.